Space travel has always been limited by one major factor: speed. But what if there was a new way to travel that defied the laws of physics as we know them and allowed us to travel vast distances of space? That's what Elon Musk and NASA are hoping to achieve with their new light-speed engine. In this video, we'll take a look at the concept of the helical engine, the challenges facing its development, the potential applications for space travel and beyond, and what this all means for humanity's future in interstellar space. So sit back, strap in, and let's explore the universe at the speed of light. For years, humans have been working really hard to make the dream of interstellar travel a reality. But when it comes to the vastness of space, even our most advanced rockets fall woefully short. We can travel fast enough to escape the gravitational pull of our solar system's sun, but once we're out there, it would take us thousands of years to reach even the closest star using our current propulsion methods. In the past few years, though, a new type of propulsion has been gaining steam that could get us close to those stars in just a fraction of the time. It's called the helical engine, and it basically uses magnets to fling a spacecraft forward at unbelievable speeds. The helical engine works by accelerating ions to relativistic speeds in a closed loop, and then slightly varying their velocity to change their momentum. This would create thrust without the need for any ejection of propellant, meaning that it could be used for long-term satellite station keeping or interstellar travel. The key advantage of the helical engine over traditional designs is that it has no moving parts other than the ions themselves, which makes it much simpler and more reliable. Additionally, because there's no need to carry propellant, a spacecraft equipped with a helical engine would be much lighter and more fuel efficient. The concept of a light-speed engine dates back to the late 1970s, when U.S. inventor Robert Cook patented an engine that supposedly converted centrifugal force into linear motion. Then, in the early 2000s, British inventor Roger Shawyer proposed the EM drive, which he claimed could convert trapped microwaves into thrust. However, it wasn't until recently that Elon Musk and NASA revealed their own version of a light-speed engine. This new engine is said to defy physics and could potentially revolutionize space travel as we know it. So far, the only thing that's been holding this engine back is its lack of speed. But with further development, there's no telling what this engine will be capable of. It has the potential to change the way we travel not only in space, but also here on Earth. With its ability to reach high speeds, it could potentially be used for long-distance travel and make our commute times a lot shorter. There's still a lot of testing and development that needs to be done before this engine is ready for public use. But if all goes well, we could be seeing a new era of space travel in the very near future. It's difficult to say whether or not we'll see practical applications of this technology in the near future. The concept is still in its early stages and has not yet been proven to work. However, if it can be demonstrated to work in a frictionless environment, there's potential for it to be used in space propulsion systems. Even if the concept is eventually shown to be feasible, it's likely that it would take many years to develop and perfect the technology so that it could be used practically. Thus, at this stage, it's difficult to say whether or not we'll see the applications of this technology in the near future. Even though major milestones have been achieved in making it a reality, there are still a number of challenges that need to be addressed before this technology can be deployed on a large scale. One of the biggest challenges is power requirements. The engine needs 165 megawatts of power to generate just 1 newton of thrust, which is about the same force you use to type on a keyboard. This means that it would only be able to reach meaningful speeds in the frictionless environment of space. Another challenge is efficiency. The current design is massively inefficient, with only a small percentage of the energy used being converted into thrust. Finally, there's the issue of conservation of momentum. In order for the engine to work, it must violate one of the most fundamental laws of physics. Despite these challenges, scientists remain optimistic that his design can be improved and eventually deployed on a large scale. If the engine performs as well as Elon Musk and NASA say it does, then it could have profound implications for humanity's future in interstellar space. With a reliable means of propulsion that can travel at near light speeds, we would finally be able to explore the vastness of the cosmos and potentially find other habitable worlds. This would be an incredible boon for science and our understanding of the universe as a whole. Additionally, it could lead to new technologies and industries being developed in order to exploit this new form of transportation. All in all, the potential benefits of this engine are huge and could very well change the course of human history. The role of Elon Musk has been key in making this possible, as he's always supportive of new and innovative ideas. He's also been a big investor in this project, which has helped to make it a reality. NASA has also played a vital role in this process, as they've provided the research and development necessary to make this light-speed engine a reality. Without their expertise, this breakthrough would not have been possible. Elon Musk and NASA have worked together to create something that will change the way we travel forever. And this looks like just the beginning of mankind and space exploration. We can only hope that this technology will be used for good and help to further our understanding of the universe. In order to achieve success in the helical engine project, there's a continued need for investment and research into advanced propulsion methods in order to achieve success in the helical engine project. NASA has given $5 million for the project in order to continue its development. The helical engine is a new type of propulsion system that uses a series of magnets to create a magnetic field that propels an object forward. The engine is still in the early stages of development and needs continued support in order to reach its full potential. Helical engines have the potential to revolutionize space travel by providing a more efficient and environmentally friendly way to propel spacecraft. With continued investment and research, the helical engine could one day make interplanetary travel a reality. Why do we need a light-speed engine? For one, current methods of propulsion are incredibly inefficient. It takes a lot of energy to move an object even a small fraction of the speed of light. With a light-speed engine, we could potentially travel much faster while using less energy. Additionally, a light-speed engine would allow us to explore the universe in ways that are currently not possible. We could visit distant stars and planets in a relatively short amount of time, which would allow us to collect data and samples that would otherwise be unattainable. Finally, a light-speed engine would have military applications. If we could develop a spacecraft that could travel at the speed of light, it would be virtually impossible for an enemy to intercept or attack it. All of these factors underscore the need for a light-speed engine. Such technology would have a profound impact on both our scientific understanding of the universe and our ability to defend ourselves. We're currently limited by the speed of light, but with a light-speed engine, the sky is literally the limit. In conclusion, we can see that the potential benefits of a light-speed engine are vast. It could potentially revolutionize space travel and allow us to explore the universe in ways that are currently not possible. We could only hope that this technology will be used for good and help to further our understanding of the cosmos.